and welcome to the largest of the science breakfasts in New South Wales. We're delighted, and congratulations to Thomas, because this is a record turnout. So there might be a few people who don't know me. I'm Mary O'Kane, the Chief Scientist and Engineer here in New South Wales. And it's fantastic to welcome you here on a grey day to a tremendous topic with a wonderful speaker. Thomas Maschmeyer is one of those people, you can read his bio on the flyer, a very famous chemist, member of many academies, been given a great number of awards, very deservedly, been an advisor to governments, and I particularly want to thank him for things he did for me in the period at ACRE, for the Australian Centre for Renewable Energy, very famous in renewable energy. But he's the sort of academic researcher that the Prime Minister talks about. I think he's the ideal. Somebody who is a great researcher, fantastic teacher, great leader of his group and with his PhD students, but he's founded several very successful companies in a very important area for Australia, renewable energy, sustainable energy, energy storage. And they are successful, and they're not just Australian companies. He's done it around the world. But here, of course, well known for companies like, probably Licella's the most famous, but there's more recent ones like Gellion. And it's good to see them developing and those companies being themselves multinational companies. Now, he's not quite the only one. We've got one or two other academics of that type actually in the room here from New South Wales, and it's something I think that we can be enormously proud of, to see the commercialisation successes in these high-tech areas led by great research leaders like Thomas Maschmeyer. Ladies and gentlemen, please welcome Thomas, who's going to talk on creating the future.
Well, thank you very much for that amazing introduction. Now I've got to live up to it. The most ideal person. That's nice to hear. My wife is in the audience, so... So you saw the talk, the title of the talk. So I'll be talking about... I'll be talking about innovation, commercialization of sustainable technology. And I'm a good academic, so this title is quite dense, and there are some assumptions in that title, so I'll unpack some of those assumptions for you. The first one is that I believe we have a sustainability crisis. We have issues with the supply and guaranteeing of clean water, fertile lands, and we all know about the climate situation. Now, if you think that is the only thing we have trouble with, we really have trouble with also the amount of land mass we need for a sustainable life on this planet. So here on the x-axis you can see years, on the y-axis quite an unusual unit, planets. So currently we are using the resources of around 1.5 planets, and clearly we only got one, so that's a bit of a problem. If we go further, we can either do business as usual and end up using about 7 planets, maybe it doesn't matter anymore, or we can turn things around and go down back to about 1 planet. Now this work has been done by a Swiss charity, very precise people, possibly a little bit dull, but I can say that as a German, right? So how do you make a Swiss person smile? Put a gun to his head and say smile. Apologies to any Swiss who are smiling right now. So what they do is they calculate intervals, and they only ever publish the lower bound of those intervals to be really sure that what they publish is quite conservative and reliable. So that's the lower bound. You can do this for yourself by looking at these websites, and in fact, if the whole world was living like us in this room, we wouldn't just need 1.5 planets. Currently, we need about 6 to 7 planets. And you can play it around on these websites. If you take the bicycle to work, well, will I save a planet or not? So it's quite instructive, quite instructive. So therefore, I think it's fair we have a crisis in this area. And if you still don't believe it, we currently burn in 1 year around 1 million years of accumulated fossil resource. So that's sort of pub test-wise, pub quiz-wise, it's obvious we can't keep doing that. Right, more assumptions. And I believe the economic system has a bit of trouble as well. And why? Because currently this idea of quantitative easing, printing money, is not really delivering the results that people were hoping for. Negative interest rates, central banks, etc. So that's all a bit unusual. And in the advanced economies, which have been chugging away nicely, we are seeing now an increased wealth polarization, and it's not good for GDP growth because there are not that many people to buy the things that we want to sell. And this is all not controversial. These sorts of assumptions are really a broad consensus, reflect a broad consensus across the political spectrum. So people who are interested in facts and then forming an opinion will sort of land somewhere here, irrespective of their political color. Crisis. So in Chinese, the word crisis is a composite word, I'm told, and it is made up out of these two characters representing danger and opportunity. So this morning, I don't want to focus on the danger bit more than I just have. That's it. You can look at the newspapers, at radio, television, whatever you fancy, and I will want to just focus on the opportunity that is inherent in crisis. So what is that opportunity? Well, the nice thing is everyone agrees that innovation is the key to moving forward. Innovation is the key opportunity. And innovation has been used and abused quite a bit. Innovation Nation, if you like ABC's Utopia, it's trending on the Twitter sphere and all the rest of it. So I just want to quickly go through what innovation means. So I went to Merriam-Webster, and they're saying that innovation can refer to something new or to a change made to an existing product, idea, or field. And to illustrate that, they came up with this example. One might say the first telephone was an invention, fair enough. The first cellular telephone could be either an invention or an innovation, taking something that was there and making something else out of it. And certainly the first smartphone would be an innovation. So just for definitions purposes, I think that's the sort of way I like to use the word. My strategy regarding innovation is I want to address real pressing problems with new technologies that we develop at the university and through collaborations. With that, I want to create solutions that serve existing or create new markets, and I want to do all of that by using economic forces to drive change. So no revolution yet, contrary to Sydney Art School, I think, yesterday. No revolution yet. I want to use existing systems to make change happen. And because I'm German, it's just not exciting if there isn't a little bit of a flavor of world dominion. So I like to think about these things as making global impact. And you may think I'm crazy, but there we go. Now global, you probably realize, is quite large. And we have some astronomers in the audience here, and so they think of the world differently. Global is nothing. If I look at my telescope, I have a lot of stars out there, and the planet is nothing in size. So we can take heart that there's more than us out there. And in deference to Tim Benning, who's one of the main stars in that field in Australia, I thought that was an example to choose. So we can take some heart from that, and it's still big though. Let's not change the universe, let's just change the world. And global, of course, needs a lot of cash. That cash needs to be invested, not always the same, and then we need to have resulting growth to push things forward. And so the question is, how does one size such a transformation? How much investment is actually needed for this to occur? So this is my favorite little formula, and that's transformation equals size of vision times an ability to deliver divided by fear of failure. So, if you believe you have a great vision and you have no fear of failure whatsoever, but you've got zero ability, not much is going to happen. Think X factor. But of course, it's obvious. So if I have much fear but vision and ability, I also don't achieve much. So I should say that I pinched this formula from our chief scientist, so you can see the formula there behind him. So I thought that if I acknowledge publicly I pinched something, that's okay. That's what I learned from how Wall Street dealt with the subprime mortgage crisis. So anyway, so I've added some value here, and that gives us, I reworded it a bit, and transformation equals vision times competence divided by anxiety. And just to put the science into social science, I then abbreviate that and make V times C over A. All right. So let's examine this in the Australian context. Competence. Australia has absolutely outstanding universities and research institutes. We've got to realize we are amongst of the top 50, depending on the indexes, is the Shanghai one. Of the top 50, we represent 10%. 5 universities in the top 50 in the world for a country that's 24 million people at the bottom end of the world, to be polite. That's crazy. It shouldn't happen. It's absolutely outstanding. And so we are world leading. This is something that any nation would give their left arm for, or right arm. So big tick on competence when it comes to idea generation, when it comes to depth of engagement with science and technology. What about anxiety? So many of you will say, yeah, Australia. Financial markets are global. So anxiety in that sense is global. So if I look at a developed or advanced economy, the fear is similar everywhere. If I'll talk a bit later about startups, if I try and grab global capital, that fear level is not different outside of Australia than inside of Australia. But what isn't the same are policy settings. Policy settings can change that level of investor fear. National and state policy can reduce risk and therefore help investment. And that's where Australia is not doing as well. It's lagging somewhat. It's not terribly bad. We've got the innovation statement. We're very grateful for that. So that's not the point, not talking it down. But certainly we can improve a lot. And people here in the audience who might be in that space, I encourage you to think about improving that bit. So we got a tick with some brackets around it. Vision. I think Australia has got vision. The country is characterized by vision. It's a colony that's grown over not many years into a fantastic state that's the envy of the nation, of the world. So vision is okay. There are lots of people with vision. Bipartisan vision is troublesome, and that leads to insecurity. So I think there we need to do better. And again, that bipartisan approach by politics and also by the various large lobby groups, that is really important. We need to have a bipartisan approach for long-scale, large projects. So we're sort of there, but not quite. So again, it's a tick with some brackets around it. But overall, you see there are 3 ticks. So I think we are all right. We are ready to go. We're ready to launch in some positive action. So back to global. Is making global change, is that maybe just too expensive? Maybe it's just all too hard. My answer to that is, if it's a global crisis, especially regarding sustainability, if it's a global crisis, what is too expensive? If our way of life is sort of on the way out, what's too expensive? It's good to look at history in similar sort of situations. So I'd like to argue, happy to in the Q&A time to argue, all new big technologies have come from crisis situations, all of them. And the reason is that cost does not matter when people believe their survival is at stake. That's why you can do things. And here's some examples. Hot war technologies. Accelerated aircraft design. Brothers Wright were doing their little thing, and in a few decades after that, we had bombers going around the place, dropping things in World War I already. Rocket design, obviously, internal combustion engine, a massive acceleration there. All of oil refining and non-conventional oil refining, radar technology, nuclear technology, that's all to do with crisis situations in a war scenario. Cold War technologies, well, the whole space race, internet, computers. I know there's some astronomers in there as well with Wi-Fi. But predominantly, this has come really through these crisis scenarios. So therefore, crisis is something to be wary of and take note of, but it's something that from which good things can actually come, and that's the historical evidence for that. So, cost. If I take an example of cost, let's have a look at at energy. So in 2015, there were about $329 billion invested in renewable energy. Globally, that's not so much. It's okay, but it's not so much. So Bloomberg, which is a news and sort of analysis outfit, they're reasonably conservative, they are saying that investment in renewables by 2030 will actually reach around $5 trillion per year. Now, if they say that's what's needed for an energy transformation, that's their view, are they just crazy? That sort of money, $5 trillion a year, that's a lot of money. Well, interestingly enough, the International Monetary Fund, also not particularly left-wing, they are estimating that the current implied fossil fuel subsidies across the globe are, guess what? Around $5 trillion, right? And this is not a crazy think tank, it's IMF. So, therefore, my message is, it's okay. We are sort of spending this sort of money in energy already. And again, it depends on policy settings that will redirect that flow. We actually got enough money to make things happen. And we're spending it. So enough money for global change, that was easy. Substantial competence in Australia, that was very pleasant. And I think we can easily reduce anxiety, as I said, through policy settings. And I take it that vision is not a problem, and success will inspire more success. So we have a tremendous opportunity for transformation going forward. Right, so that by way of introduction and placing what I'm going to say next. So how have I responded to this? How have I tried to interact with these sorts of ideas? Well, you can see I'm a serial offender. Meschmeyer Inc. Tried it 6 times, sometimes successful, sometimes not so successful. Zeoflex was cremated pretty early on. But, you know, things happen. I'd like to give you a bit of an idea of how you can do this as an academic and where did it all start. Very briefly, I did a PhD at the University of Sydney, at the Royal, and then I did a postdoc as Australian Bicentennial Fellows a long time ago at the Royal Institution. And the Royal Institution in London is a special kind of place because it was founded to actually do applied stuff, to help the landed gentry with their ovens and make a better frying pan. And it was founded by a German, somewhat dodgy character, Count Rumford, and he invented the Rumford stove, which is the basis for the Arga stove, etc., etc. But he very, very quickly realized that he needed some scientists there to really understand what's going on. And just across the road is the Royal Society, you know, with Newton, etc., Banks. So they said, well, maybe they've got to say something. So then they had some fancy directors. All the ones in bold and in red got Nobel Prizes. All the ones in bold would have gotten Nobel Prizes, maybe more than one, for Faraday, if they had existed. So it's a place which is absolutely full of scientific excellence. Yet, they also did technology translation. Humphrey Davy invented the Minas lamp, platinum on a wire mesh, and that allowed you to go into a mine that was filled with methane, which normally would explode if there was an open flame. But this platinum wire catalytically, I'm a catalytic chemist, so it's close to my heart, catalytically decomposes the methane and the wire just gets hot but doesn't have a flame outside the cage. And that saved not 1 or 10 or 100 lives. That saved many, many tens of thousands of lives and untold misery for British coal miners. So you can see there is an exciting translation of technology. Michael Faraday, probably the greatest scientist who ever lived, did lots of technology translation, and he invented, amongst other things, the electric motor. That's sort of important. Worked out magnetism. Well, that's sort of important, but I could go on. So again, the point here is that I've been, as a 27-year-old, I was breathing these sorts of fumes, and I thought, well, this is for me. This is really good. Let's try and keep doing that, combining scientific excellence with impact into the world. So when it comes to scientific excellence or activity, my research group is doing lots of things in nano. I'm also director of the Australian Institute for Nanoscale Science and Technology at Sydney University, which is a visionary really investment by the university. They took a big risk, but I think it's paying off. So we're doing lots of things which are nanostructured, ionic liquids, salts which are liquid at room temperature, look like water but are like table salt, all sorts of fancy things, front pages and whatever. But the point is, I'm not going to talk about this today. That's sort of 60-70% of what I do, not talking about that. Because what I'm trying to say is I have this activity, and that provides the fertile ground for technology translation. My view is, without such activity, you're not going to make it. So in this little picture then, the soil is what I just showed you. So sometimes, when students might say, oh, that experiment went to shit, I'm thinking, no, it went to soil. That's fertilizing. And then from time to time, you have a little plant growing, and that's your technology translation part. So my version of entrepreneurship is to combine an academic career with tech translation. And there are always these components which need to work together. So public R&D institution, in my view, public R&D institution, some visionary, enlightened government funding, then some people who will set up a company, and then this whole thing will be attractive enough for private equity money to come in and really kickstart the whole thing. And you see that I've highlighted people in red, because at the end of the day, that's the main thing. It's the people, it's the team, it's the relationships. Quality of ideas, but ideas actually can change quite quickly in a creative environment. So with the right team of people, you might start on a certain set of ideas, but after a while, you actually end up doing something else. But you would have never done that if you hadn't started the journey. So that's key, and I'm very pleased that there are lots of those people in the audience who've been helping me along the way over the years. So thanks for coming. The first story, so I'm going through those company stories, not in too great a detail, is Avantium. Founded in 2000, and it's now got more than 160 jobs. It's a globally operating company. So you see, when I said global, it actually sort of works. They were 5 times in a row the top global global top 100 clean tech company index, and they were Europe's clean tech of the year 2015. So really successful place. What are they doing? They're doing high throughput research and development. So taking robotics, and Hugh will like that, yes, robotics and automation, and to not only do 2 experiments or 10 experiments, but hundreds and thousands of experiments for process optimization, for catalyst discovery, all sorts of things. And as a consequence, they came up with a new polymer based on sugar, so renewable, and Bayer is making that polymer, and they just signed a major deal with Coca-Cola Amatil and Danone, and in fact this polymer will be in plastic bottles near you within 5 years or so. So it's going global into those 2 businesses within 5 years. And that's really exciting, because that's really making a global impact with renewable chemicals everywhere. So how did it get there? University of Cambridge, I was a senior research fellow there, and I was consulting for Shell. I helped them with one of their main processes, and I helped them with a catalyst, so they thanked me for making me a consultant, which was great because it paid for sort of planning for my second son. And, well, you know, academics, not much money there. And I was also consulting and having friendship with Cambridge Reactor Design. So I brought these two outfits together in the back of my house and the garden, talking about what one can do, and this spin-off was born, the idea of a spin-off. And CRD made the initial bank of reactors for Shell. And then Shell said, well, actually, this is getting quite expensive. Let's have a big spin-out and involve the whole industry. I then moved as part of that to Holland, to Delft. And what is important here, we then went to the Dutch Ministry of Finance with Shell and the three technical universities, Eindhoven, Twente, and Delft. And they were really, really enthusiastic and supportive. They didn't say, oh, well, Shell, you should pay for everything. They saw this of something of national significance. So we then set up this spin-off, and it was a consortium of these really big companies. So billions and billions of dollars you're seeing there. And that really, that collaborative aspect of it was key to it, and the personal relationships were key to it. Also, of course, at a university, it's important to educate people, and if you have a startup like Avantium, which used technology that didn't exist before, they needed people to run it. So we built a lab for training, quite expensive lab for training at my university, and then they had a separate outfit in Amsterdam where they were doing their main research and money making. So you see how it all neatly integrates, and it's a world success. So we can see whether we can do things like that here in Australia. So very quickly, the Australian biodiesel, that was something which is more of a lesson. It started, it survived, and then it died. And it was created by the Australian government starting an excise holiday on biodiesel. And so it stimulated business activity, so everything went by the textbook. ABG became the largest supplier of biodiesel. I came in, helped them to reinvent their technology. We were really going gangbusters. But then feedstock price went up, which was a bit tricky, but we could just survive. But then the government changed the excise regime again, overnight on Melbourne Cup Day. Thank you so much. And then that killed the sector, because suddenly we were from 17 cents cheaper, 25 cents more expensive. Okay, that was it. So the lesson here is predictability and stability in policy settings are really good for jobs and growth. They come together, like love and marriage, right? Anyway. Anyway, more not the marriage part, but the fact that they changed the excise law. Just to... yeah. Still got the scars. From the excise, not the marriage. Man, I'm digging myself in here, aren't I? I'm digging and I'm digging and I'm digging. So, now some good stories. Ignite Energy Resources and Licella. Ignite Energy, founded in 2006, and what we're able to do is take brown coal, dirty, horrible brown coal, and make it into crude oil. And again, the story here is some government programs, ABRI, and Mary was referring, I think, to that, and the ALDP, Advanced Lignite Demonstration Program, together with Sydney University and then the startup Ignite Energy. We were all able to get large amounts of private equity in, many tens of millions of dollars, and we have large projects shovel-ready. There is a large government grant, $25 million or so, waiting to be spent. So that is good news story, and what it does allow us is to have independence from foreign oil. So we don't need to import any crude oil, we can actually generate it from existing coal mines. It also helps brown coal power industry to transition into something new. And all those communities, all those jobs, all those schools, kindergartens, families, they don't have to abandon their way of life. They just take their product from the mine and something else and valuable is made with it. So I think that's of national importance. The other thing, the international importance bit, is one also can get away with not having to drill in pristine wilderness. Because if I look at the current amount of oil that's available, we will actually almost double that amount of oil if that technology were used globally. And that is all alluvial mining, using to a large degree existing mining activities, etc., repurposing them. So although it's not pretty to grab the top bit of the planet. It is a lot more controllable, and it can be very nicely rehabilitated. And in East Germany, where they have rehabilitated, those areas are now popular tourist destinations, because you rehabilitate with forest and with lakes into the whole, and then you put some bungalows there, and it's all good. The time frame is 50 years, not 5 years. So that's the key. That's the key. Right. Licella, and I'm even going to show you a little bit of science now. Licella is going commercial with 2 projects, and Licella's chief scientist, Bill Rowlands, is in the audience. It's going commercial with 2 projects, and what we're making is high-quality crude, really high-quality crude, out of waste, and that waste is biomass or plastics or used lubrication oils. And we can make either chemicals or fuels, depending on what we want to do. So now I'll show you some pictures of how it actually works. So here's a piece of wood, some splinter you get from assembling IKEA on the weekend, in a quartz capillary at time 0 in water. This is just water, no special catalyst. We added some bits and pieces. And then we heat that up. And we heat that up, so this is cooled down again to be able to take the picture. We heat that up so the water becomes steam, but we compress the steam so greatly that the steam behaves like a liquid. That's called supercritical, 4th state of matter, and it allows you to do lots of interesting chemistry. So after 1 minute, the wood looks a bit worse for wear. 2, 3, 4, 5, it's just a little bit of ash, and the wood has become oil, either soluble in the water, or it has, at the top there, you can see a little bit of black gunk. That's the insoluble oil. So anywhere from now on that you see a piece of wood or a piece of wood waste or biomass waste, you can think, hey, I could make this into oil. So if you had a particular tedious committee meeting and you think, well, that person is a bit of dead wood, think of this picture. You can make that person into bio-oil, and that might get you that might get you through that meeting. See, I'm trying to help. So we have here woody biomass, just some sawdust, and that sawdust is then converted with our process, and we get biocrude oil out. And this is drawn to scale, and the really, really cool thing is that you have the same amount of chemical energy in both vessels. So we have a massive energy densification, and what was wet and solid and useless and a trouble is now liquid, storable, blendable, miscible, upgradable. So big value upgrade there. How does one use that? Well, you may know in a refinery you have crude oil coming in and you distill it. In the beginning they just took a little bit of distillate and then put it in oil lamps, and then they improved. So one of the cuts of the distillation, so they're separated by temperature, is called straight-run gas oil, which in fact is the first thing they ever did with oil. And that's already a high-quality stream. And what happens is in a refinery we can add our oil to that stream, I should say. So we don't have to add it to the crude oil stream, which is lower value. We can already add it to a pre-refined stream because it's such high quality. And when we do that, we mix it. The same number of green atoms going in are the same going out. And from a chemical point of view, you cannot distinguish the products. You can do some carbon dating and work out they're a bit younger than they should be, but that's it. So they're identical in terms of products, and it's amazing that we can do that actually. So here you see some straight-run gas oil at 0, so that's nice and clean, and then we add our dirty-looking oil. It's just some very highly colored small impurities that make it look so dirty. After adding some hydrogen, it all looks wonderful. So that's what we end up doing. However, it's not even necessary. The oil is so good, it's not even necessary to do that if you don't wish to. We can put it into normal road diesel at a 20% blend, put it into a normal diesel engine, and that diesel engine, if you didn't know, in terms of performance, is identical in terms of power, longevity, etc., etc. What changes for the experts is the NOx ratio goes up a little bit because we're burning a bit hotter because we've got a little bit of oxygen in our oil. However, the particulate emissions are going down because we are burning a little bit hotter. So we're sort of winning, losing. It's more or less evens out. And if I ask VW to measure the NOx, I think we're okay. So we can do this all without needing to upgrade in a refinery, if that's the idea. So this is going so well, and this is a really major story and a major announcement, I hope people understand. So we have a 10,000 ton per year demonstration plant in Somersby, just south of Gosford, and that's on the right lower side. And that's now been taken up in a joint venture with a company called Canfor, the world's third largest pulp and paper company, and it's going to be fully integrated into one of the largest pulp and paper mills in the world at Prince George in Canada, and initially at 200,000 tons per year, and then goes to 600,000 tons per year. And of course, once you've done that for one pulp and paper mill, you keep doing it, cookie cutter model. So remember when I said global? It's sort of true. It actually works. One does just have to have the vision and the reasonable lack of anxiety. I think there was still a fair amount at times. But we are now there, and in the whole biofuel, biomass, whatever sphere, it is the biggest story worldwide. We are leading everybody. And this is Aussie technology, owned by Australians, developed here, going global in the green space. So I think that's a story we need to celebrate over and over again, not just to make me feel good, but also to inspire other people's ideas and belief. We can also go smaller in size and go for a 20,000 ton a year plant, because some feedstocks are better sized that way. And we are able to take what's called end-of-life plastics, the plastic you cannot recycle anymore, but is too toxic to burn, that normally goes in landfill. And we are able to take that with a smaller plant, you can see here, and make, lo and behold, diesel and gasoline blend stocks, so things that can be mixed in or polished in a refinery, whatever one likes, from that. So we take horrible toxic plastics out of landfill, and we can make something useful there. These are those technical details. We can process mixed plastics, which is unheard of. We don't produce dioxins, which is amazing, and we don't need this gas cleanup, which makes it a lot cheaper. Again, for the specialists, they might get excited about that. Right, so how am I going for time? So the last story is gelion, which people have trouble pronouncing. I thought it was so easy, gel, iron. Yeah, a gel and an iron, gel iron. But gelion, anyway, it's quite funny. So gelion was founded in 2015 as a spin-out from Sydney University. And before I talk about it in more detail, just like to point out that the global lithium battery capacity right now, everything that you can think of, whether it's in your camera flash or whether it's in your car or whatever, everything put together equals 46 seconds of the daily electrical energy use of the world. So why am I saying that? Well, I'm saying that because there are lots of announcements by people saying, we've got the new battery technology. It will blow everything up out of the water. We will really shoot people to the moon with this, etc. And we will be dominant. The world has such an enormous need for batteries at a reasonable price point that it's just close to impossible to actually make them all. So therefore, as long as the price point is sort of okay, there's a market for you. We cannot supply that market quickly enough. So we can all play, and some, maybe in 50 years or so, there will be a technology that's actually the dominating one. But currently, we're in a situation where lots of different technologies, a bit like evolution early on, big dinosaurs, small dinosaurs, flying dinosaurs, and some of them will survive and others won't. But currently, the world needs as many batteries as possible. So we founded it, Sydney University spin-off, so we launched a patent. The patent then was bought for equity by Gelion. So Sydney University now has got a model that really says open for business. They're very keen to translate their IP. The barriers are now very low. It's very attractive for companies to come in. Hasn't always been the case, but there's been a big change in attitude. And I think the fact that all three, Vice Chancellor, Deputy Vice Chancellor, and Pro Vice Chancellor are here today to support that statement makes a statement in itself. So Sydney has commercialized this. Again, ARC, Australian Research Council, helped this whole thing coming off the ground. and we got private equity money in, and now we just raised 11 million for that. Key about the batteries is that they're fire resistant, they are flexible and inexpensive in their chemistry, and we have a platform type technology. The market is to incorporate them into prefabricated walls for storage in buildings, and that allows you to envisage large buildings to be basically just big batteries. And if you have enough of them, what that means is that you actually can get your base load from batteries, which absolutely and utterly changes the paradigm how we generate, distribute, and use electricity. It really is a game shifter when we get that to that critical mass. And we don't need, a central power generation with large transmission distances where I'm losing most of my power over 2,000-3,000 kilometers. I can be nimble, I can be flexible, I can be distributed. Also, when I give this talk in America, terrorists can't hit you so easily, so that sells over there. So we really can make a massive difference with battery technology, and that's why currently in the world everything is every country is going very well. All right, I've got one more slide. I see people are getting nervous. So that's my last slide, and that is, again, basically reposing the question by my DVCR, who said, well, how do you do all this stuff? What's the special sauce? Just tell us to be able to have other people do it. Well, first of all, I should point out that you see that picture there from the Australian Financial Review. Unless you can take a prop and look at that prop pensively, don't start. That's the prerequisite. Unless you can do that, don't get out of bed. Now, the next point is that, of course, there's not just one way. There are many ways, and I've just showed you my views and philosophy. Very important to understand business basics, and my long-suffering business friends in the audience know that can be a challenge for an academic. Really important is to set out to strive to succeed and not to strive to avoid failure, because you're going to fail anyway if you're going to fail. So you might as well have a very positive go. Don't say, I could have been someone, I could have been a contender, but just go out there and do it. Relationships, very important. Again, challenging for academics. Not just IQ, but EQ, emotional quotient. So focusing on those relationships, very, very important. And that means one speaks to the other party's needs. And I put this in for my wife here. No. And of course, to develop a common vision is very important. Another thing that investors like is if one is strong enough in one's belief to have some skin in the game in some way, some financial penalty, some other whatever, something that they say, yes, this guy is for real. That's really important. And the final bit is you need to be able to weave a dream and really excite people. So I hope that with this talk this morning, I've been stimulating you to go out there and try weaving your own dreams for the good of the nation and the good of the planet. Thank you very much.